Use the graph to write the formula for a polynomial function of least degree. Okay, so we just start with clues and fit those clues to the polynomial. So first off, one easy thing to identify are zeros. So zeros, the graph is either going to touch the x-axis or cross through the x-axis. So the zeros of this polynomial function are x equals -1 and x equals +2. Now, we can also identify from the zeros its multiplicity, because at -1, the graph touches the axis and then bounces back away. It sort of looks like a parabola. Parabolas are degree 2, and what that indicates is that this 0 is multiplicity 2. And similarly, the graph just crosses right through the axis here, so that looks like a line, which is degree 1, so it's multiplicity 1. If you add up your multiplicities, that should give you the degree of the polynomial. So we should have a degree 3 polynomial in the end. And that matches up as well, because if you look at the end behavior, we start in the negative direction and end in the positive direction. And that's consistent with a polynomial of odd degree. So that the multiplicity, the total of the multiplicities is 3, matches up perfectly. So right now my polynomial looks something like f of x equals some value that we don't know yet, just a constant multiplier, times x plus 1. So I'm taking the 0 of -1, changing it into a factor just by adding 1 to both sides. But since it's multiplicity 2, I'm going to square it. And then I'm going to multiply that by x minus 2, which, because I have a 0 of 2, I can change that into a factor of x minus 2. And now I just need to figure out what the value of a is. The value of a, an easy way of doing that is to pick some point that's visible on the graph. So this would work, -4, 1. Or actually, sorry, I reversed that. It's 1, -4. Another point that would work just fine, which is usually very visible, is the y-intercept, and that y-intercept's coordinates are 0 and -2. So what we can do is, knowing an xy pair, we can substitute the y in for f of x, and the x, of course, in for these x's, and the only thing left would be the value a, and it would allow us to solve for that. Now, any point on the curve will work, so pick the easiest one you can. So I'm going to go with the y-intercept because that leaves a 0 for the x value. So that means -2 is equal to some value a times 0 plus 1 quantity squared times 0 minus 2. And let's see what we get here. So -2 equals a times, this is just 1, so times -2, or a equals 1. So that means my polynomial is in fact just x plus 1 quantity squared times x minus 2.